Welcome everyone. This is MicroK8s. I have Philip Williams with me from the Ceph team in Canonical. I'm an engineer in the Kubernetes team at Canonical, and Phil is a product manager. And we're here today to talk to you about how to use Ceph storage on MicroK8s with MicroCeph. And thankfully, without further ado, I have Phil with me to fill in the blanks that I have on the Ceph-related things. So Phil, if you are ready.
Yeah, sure. Hi, everyone. I'm Phil Williams. I'm the product manager for Ceph and all things storage at Canonical. So we just wanted to take a few minutes, just talk about what MicroCeph actually is, what it isn't. And then we've got a quick demo of just doing a small deployment that we'll run through as well. Then I'll hand back to Angelos, and he'll go through the integration pieces with MicroK8s. Can you hit the next slide for me?
Yep, I will for the next slide, please.
Yeah, sure. So what is MicroCeph? So micro by name, still mighty by nature. It is still a real Ceph cluster. It's just deployed using a snap, which keeps things nice and easy, nice and consistent. So if you think about those kind of environments where it's the middle of nowhere, you've got like a 4-node cluster at the bottom of a cell phone tower, and you just want something quick, simple, absolutely repeatable. This is the kind of place we expect MicroCeph to be used. The great thing about snaps is that when we do things like upgrades, or when we have a new version of Ceph added into the snap, it really just means that a quick refresh and you get a new Ceph, or you get an upgrade of the Ceph cluster. There's no super overhead into doing things like upgrades. And in terms of doing hardware additions and things like that, we've built in some great functionality just to make those steps really, really easy. You'll see them in the demo. Next slide. So if you think about what I said about it's still real Ceph. It's still all of the Ceph that you ever want, but it's Ceph for non-experts. So by Micro as like a brand for us is a bit like low ops. It's not a case of having to be a complete expert with Ceph. And again, that fits with that remote location where you don't necessarily have a Ceph guy on hand to go and deal with something themselves, or can't get hold of them on the phone, they can't get in remotely, those kind of odd situations. One of the wonderful things about it, and what we actually demonstrated at Cephalicon earlier this year, was that it scales from both like a dev use case that runs on my old 2015 MacBook Air, all the way through to a data center scale deployment. And as in the future, once we test further and we fully understand all the scaling of the clustering that we've built to make this thing work, we fully expect it to scale to normal size Ceph clusters of tens to hundreds and maybe even thousands of nodes. Right now we've tested kind of small scale 10-ish nodes. So yeah, it's still it's still kind of in its early days for us, but it's still a very robust way of delivering that small use case. And of course, it's Ceph, so it's reliable, it's resilient. Ceph's number one job is to keep data safe. It's the founding founding thought of a Ceph cluster, so that still remains. And we have great flexibility. Object storage, block storage, file storage, all available from that single cluster. And one of the most common requests we see in Charm Ceph is around having encryption at rest. So we've made sure that that's built in from day zero, so that when you do a deployment, you can deploy those disks as fully encrypted. So then you don't have to worry about things, like when a drive fails, or worse, a drive gets stolen. You don't have to worry about somebody being able to retrieve data from there. And next slide. The install is super easy. I think there's there's 8 commands here, and maybe a couple of those you would repeat, and this will get you a fully functional Ceph cluster on a small number of nodes. If you go to microceph.com, it'll take you straight through to the Snap Store, which will give you more information, and also be able to get the docs from there as well to help with any deployment challenges you might run into. Next slide, please. I think this is now time for a demo, and if Peter's here, he's going to walk you through it for me. This should autoplay when it loads.
Okay, you're playing it? Oh,
Yeah,
I
it's
see.
good.
Excellent. So this demo is about setting up a 3-node MicroCeph cluster. The recent versions now can also run on a single node, but so this is the multi-node case, which is more interesting anyway. Just installing the snap 3 times here, and then we need kind of a head node, so the bootstrap node, and bootstrap the clusters. This is similar to what you would do with other of the micro cluster products. And then cluster up the nodes by running the cluster add command for the other nodes and joining up the other nodes to the bootstrap node. So there's a bit of copying of keys going on here. Right. So this takes a little time in the demo. I've sped this up, of course, a bit. And what we have now is a Ceph cluster, but we also see we don't have any disks here. So that is not really useful, even though it's up and running, or it claims to be up and running. So let's add some disks. SSHing into each individual VM. So these are VMs that have an additional block device added, dev SDB in this example. And I'm adding that to the nodes, and then we can see as the OSDs come in. So that's a fully functional Ceph cluster. That's nice. One common use case is to have the S3 compatible Rados gateway running on that. So this is what we enable next. That's a single command. And if you run status again, you will see on the first node that we have a Rados gateway service running now. Next step is configure a user and keys for this. So this went by a little quick, but you can see a key for the Rados gateway up there. For the demo, I'm running a small Python script to upload some binary blobs with the keys that come from the setup, and then you can access it like any S3 store you would with the keys configured in the S3 here. So that went by a little quick, but yeah.
All right, I tried to pause it on the last second, but I couldn't.
Yeah.
I knew we wouldn't have much time, so I made sure that it was pinned like bang on 2 minutes and 55 seconds. So it would be super quick.
Cool. Yeah. Any questions around that?
There is one question in the chat from Jake.
Right. Yeah. So we have 2 different kind of services running in the MicroCeph. So there's automatic services like the monitors or MDS, or indeed the dashboard, and the manager service. Those are started automatically. Rados gateway, usually you want to control on which node that runs. And not all users want to run it, so this is an extra step for Rados gateway. The others are started automatically.
Let's get on to it. Thanks a lot, Phil and Peter.
Thank you.
Yeah, let's talk a bit about now why would we want to use Ceph storage in a Kubernetes cluster. And this is a terrible graphic I made, trying to show this in a slide. So let's talk a bit about distributed storage first in Kubernetes. So in general, Kubernetes tries to solve the problem of orchestrating a large number of containers, right, at scale. So I want to run my machine learning workloads, my video transcoding pipelines, whatever. But the problem is that I want to get the results out of all these things, and I have to store this somewhere where I know it will be available, not just on the disk on a local host in ephemeral storage, because it's ephemeral. So that's where CSI comes in. Kubernetes basically says, look, I cannot solve this for all the use cases of all the people in the world, so I will just give you an interface. You, as a storage provider, you can use whatever you want. You just have to implement this interface. Right, so this means that when you want, as a Kubernetes cluster administrator, what you typically do is you deploy a CSI driver, which consumes storage from the place that you want to. Which CSI driver do you deploy? That depends on where the cluster is running. So if you are on a public cloud like AWS or Azure or something else, you might want to use the CSI driver that gives you an EBS volume on AWS, Azure file on Azure, etc. If you're on a private cloud, then perhaps, again, that would be maybe, for example, on an OpenStack cloud, this might be the Cinder CSI driver, which will basically set up a Cinder volume and mount it to your VMs. Now, if you are on bare metal, you basically don't have anything out of the box. You have to deploy your own storage solution. You have to bring your own storage, as they say. So there are quite a few solutions to that. The most common one that we go for is Ceph, precisely because of the reliability, the flexibility, and all the other nice qualities that Philip talked about earlier. So Ceph CSI driver it is. That means we have to deploy a driver in Kubernetes saying that here is your Ceph cluster. We have deployed it somehow, and now I want to use it in my Kubernetes cluster. Basically, there is the Ceph CSI project, which when you request a persistent volume, it says, okay, perfect. I want to go to this RBD pool in Ceph and create a new volume for RBD and mount it on your node, and then you can use it from your containers. The good thing about it is that it's well supported. It's a very healthy project. It has a lot of contributions from quite a few different companies, and further, it also supports not only Ceph RBD but also Ceph FS. And the important thing about Ceph FS is that it gives the very valuable read-write many PVC support. So that's for every Kubernetes cluster. What do we have in MicroK8s in Kubernetes in MicroK8s 128 for this? So we have written a new add-on called RookCeph. And it's very simple to deploy. It's simply just one command, MicroK8s enable RookCeph. And what does it do? It basically deploys the Rook operator inside the MicroK8s cluster. Now Rook, as you might know, Rook is a Kubernetes operator to deploy or use Ceph clusters in Kubernetes. So instead of having Ceph commands or stuff like that, you typically use Kubernetes resources. So if you want, for example, one case for this is if you want to create a lot of RBD pools or Ceph file systems or all that, this can either be done manually on Ceph or with an automation tool, or you can have resources inside Kubernetes, and the Rook will do the right thing for you to reconcile the state in the cluster. In general, there are two main functionalities that Rook is used for. One is to deploy a Ceph cluster inside the Kubernetes cluster and use disks from the Kubernetes nodes. That's sometimes an option, but not always. For example, there might be a scenario where you have a data center somewhere and you want to run 3 or 4 or 5 clusters, but you only have 3 storage nodes. So you cannot really say that I will deploy a Ceph cluster on my Kubernetes clusters. It has to be somewhere else. So the most important thing we want to highlight and want to show to you is that you can use it to integrate with any external Ceph cluster. Which means that in our case, we can use MicroCeph, as Philip explained previously, very easily set up an edge Ceph cluster somewhere, and then integrate with it from MicroK8s in a very easy way. Now, why Rook? Why not do this manually? Why not deploy Ceph CSI manually? Quite a few reasons. One is that Rook has a lot of automation already built in to detect the right version of its component that you need, as well as help you, upgrade and move to newer versions as they become available. Optionally, as I said previously, you can use it to manage the Ceph cluster if you want to from Kubernetes resources. Might work for you depending on how you manage your Kubernetes deployments. It greatly simplifies what kind of authentication you use for Ceph. So you have to create some clients. Obviously, the RBD node has to talk to Ceph, and it must have some required permissions. Rook can help automate a lot of this. And finally, as I said, you can, if you want to, you can also deploy a Ceph cluster in the Kubernetes nodes. but that is not what we're going to be talking about today. So let's talk a bit about, okay, what's the process of installing MicroK8s and MicroCeph and connecting the two. So Philip and Peter talked us through before, but we'll use a different machine because they have encryption at rest, but we have nothing to hide. So install MicroCeph, add some disks, and check that you have 3 OSDs and they are up and the cluster is healthy. Secondly, install MicroK8s and wait for it to start. I expect most people here will be familiar with this, but it's literally just a simple command, so it should work very easily. Then we enable the Rook set pattern, as we explained previously. This will go and install the Rook operator with the health charts and set up any configurations and everything that you need. And it will also print a helpful message saying that, look, you can now either deploy a Ceph cluster with Rook, or you can use the new helper command, MicroK8s connect external Ceph, and connect with your Ceph cluster wherever it is running. So final step, great. We have MicroK8s and MicroCeph running on the same machine. Great. MicroK8s connect external Ceph. Nothing else we have to do. It will automatically say, okay, I'm looking for MicroCeph. I found it. Perfect. I connect to it. I create whatever is needed, set up the Kubernetes resources. And after a while, you get a storage class FRBD that you can use in the cluster and say, perfect. When another request for a persistent volume, I can get an RBD volume inside. So what does this command do? It will automatically connect to the Ceph cluster using the Ceph keyring and the Ceph conf file that it uses, and initialize the RBD pool if we wanted to. It will check which Ceph CSI version we want to deploy, and rather which one we have to deploy, so that everything works without issues. Generate authentication clients, all of the permissions, and set everything up. And create resources in Kubernetes secrets and all that, describing where are the Ceph mons, which RBD pool we want to use, and all the other configurations. And finally, create storage classes, the Ceph RBD storage class we saw previously. Now, I'm talking a bit fast about this. If anyone has any questions, please write them on the chat and we can discuss about them. Now, some scenarios, some things that, some helpful scenarios, some common scenarios rather that we have met. One is at a very simple deployment, literally at the stage of a proof of concept maybe. Somewhere, deploy MicroCeph, deploy MicroK8s, just connect the two, and you get, you have your RBD pool inside Ceph, and you have your storage class in Kubernetes. Then a bit more complex scenario. Let's say we have a deployment where we have separate tenants, or we want to use an RBD pool with SSD disks. Again, this is not something specific. It's just an example to show that we can do all this stuff with MicroCeph and MicroK8s as well. Essentially, the important thing is this thing here, where you can say, oh, wait, okay. So you don't necessarily have to create an RBD pool. You can say, here's my RBD pool. Please go ahead and use it. And that's what MicroK8s will do. Then CephFS, if we want to. We create a CephFS. MicroCeph is running the MDS service already, so nothing else to do there. And then if we just, again, run the same command, we'll also get a second storage class called CephFS, which we can use for read-write many volumes. And finally, in the case where you have any other cluster, you deployed it manually, you deployed it with CharmCeph, you deployed it with whatever method you prefer. You can just say, okay, here's my Ceph conf file, here's my keyring, and go ahead, connect to it, and set up everything else. So that's about it. As a final thing, how can we try this out? As we showed in the slide previously, it's simply to install MicroK8s. There are steps, there is documentation, and that's about it. Again, some useful links and what is coming, which, as we would have you believe, these are not all coming. Some of these have already happened, but it's fine. Yeah, so that's everything. Thank you all. Any questions? Anything you want to discuss about?
Okay. David?
Yeah, just a quick question. I know that there was earlier on in MicroCeph, there was the sort of a one-to-one mapping between the mons and the physical storage. Can we split that yet? Can mons be used on partitions of the storage?
So I don't know, Peter or Philippe, did you get the question?
Yeah, so hard disk partitions you're referring to, right? So currently we can't use hard disk partitions, only complete block devices. This is not really a MicroCeph thing, but more a snapd confinement limitation.
Okay, thank you.
I also see a question from Fibos in the chat. Use cases, what are the top that come to mind? Philip, would you like to take this?
Use cases for Ceph are super wide in general. The combination of these two things. There was a good example I saw last year. It wasn't actually using MicroK8s. It wasn't using MicroCeph, obviously, but it was in Chick-fil-A in the US. They were basically putting like small, like a cluster of 3 like Intel NUCs in each retail outlet. That would run a Kubernetes cluster, would also have some local storage, and that would provide all of the stuff to operate, a retail outlet. That kind of use case is really interesting because it's like there's no IT support on hand. You've got tens of thousands of stores. It needs to be super simple, super basic. That's the one. To have like a non-IT person go and deal with that environment. So I think that that kind of scenario is perfect for this combination of the two pieces of software.
All right. Any other question for Ceph or for MicroK8s or? So we are right on time. There's still 2 minutes to go. I was thinking that today we are going to go over the time. So basically, this type of slot is for MicroK8s community. So we have this every Friday. So it is a place that you can come and share your ideas or make questions to our development team. But you can also share what you are working on or what you are working as a private home deployment. So we see this slot not as for MicroK8s, so we see this slot for the community. And you can also drop ideas on what you want to know more or what is the use case you have that you want to get more information on, and then we are going to address it in this type of slot. So feel free to approach us in the MicroK8s Slack or in any of the ways that you can approach us, like a meetup, even in a YouTube channel. This session is going to be uploaded to YouTube because the idea is that we take advantage of this session on the things that you need to get more information or support the MicroK8s community. So for today, thanks a lot, Angelos, Peter, and Phil. And there is still 1 minute for last question, or maybe we go for straight to the weekend.
Thanks, everyone. This was a great presentation.
Thank you.
Thank you.
All right. Have a nice weekend and see you in 1 week.
See you later.
Thank you. Nice weekend. Bye. Bye.
Thank you, everyone. Bye.